Hey guys, welcome to chapter 12. So, in chapter 12, what we're going to talk about is something called functional groups. So, functional groups are going to be things that we attach to these organic molecules. And these functional groups have a lot of the same characteristics no matter what we attach them to. These functional groups in higher level organic classes will give you an indication as to how it's going to react, what it's going to react with, how to classify that molecule. So my job is just to give you a brief introduction to the functional groups and just to get you thinking about what they look like and some of the characteristics. So just scratching the surface here. All right, so the first three functional groups that we're going to talk about and that are going to be in this particular lecture are alcohols, thiols, and ethers. So the first one we're going to talk about is an alcohol. So an alcohol is this hydroxyl or this OH group attached to a carbon. Let me get my pointer here. So here we see an organic molecule. We've got one carbon atom here with 3 hydrogens. It's attached to another carbon atom here, hydrogen, hydrogen. And this would be an example of our alcohol group here. It's an O and an H. So that's how we identify alcohols. Okay. So the first thing you're going to be able to do on an exam or quiz is identify an alcohol. So anytime you see an OH attached to a carbon, you're going to say, hey, that's an alcohol. The second thing I'm going to test you on are what I like to call fun facts. So I'm going to tell you some interesting alcohol compounds, some fun facts about them. And so you'll see multiple choice questions with these fun facts in them. So ethanol is probably one of the most popular alcohol groups. So ethanol is formed by fermentation of grains, sugars, and starches. Ethanol is found in most of your alcoholic beverages. It's been known since prehistoric times to be an intoxicating product. That's something that I think is very well explored these days as well. The other thing that you'll see is this OH group attached to our benzene ring. So remember, this guy right here is benzene. So I depicted it a little bit different. This is the lazy man's version that they show. I depicted it a little bit different in the last chapter. So we've got that 6-membered closed ring, and then we had every other bond was a double bond. So that was our benzene. When we have these aromatic compounds, remember we talked about benzene being involved in aromatic compounds. When we have these aromatic compounds, we often see an alcohol group sticking out, okay? And we call that phenol when it's attached to benzene. But these alcohol groups that you see attached to these benzene rings are among some of the most popular aromatic compounds. So if you look closely at this picture, you'll see that this molecule right here gives nutmeg its odor. You see this molecule right here is the smell of thyme. This one right here is cloves. And this one right here is that vanillin we talked about last chapter. So it gives vanilla, its vanilla scent. So again, just an alcohol group, being able to identify it. And then a fun fact about it is when it's attached to a benzene ring, it's very often part of our aromatic compounds. Okay. Another place that you'll see alcohols is in lots and lots of steroids. So steroids, we're probably not going to get to this chapter, but steroids are compounds that are in our bodies. And they are things like estradiol, cholesterol. So these steroids have a lot of uses with our body function. So what we see here is the huge estradiol molecule, And again, sticking off, we see the alcohol and alcohol. Here's cholesterol, which is another steroid. It's actually a steroid. It's not one that you probably typically think of, but cholesterol is a steroid, and we see that alcohol group sticking out to the end there. You would also see it on things like testosterone and those other steroids that you typically think about. Okay. The next functional group, so that was alcohols. The next functional group is a thiol. So a thiol is going to be an SH, so a sulfur and a sulfur and a hydrogen attached to that carbon atom. So here's our carbon with 3 hydrogens. Here's our other carbon, hydrogen, hydrogen. And then up here is our thiol group, our sulfur and our hydrogen. So again, you see a sulfur and a hydrogen sticking off of a carbon, identify that as a thiol. Okay. Thiols also have very distinct odors, but their odors tend to be disagreeable. They stink. Okay. So how do I know they stink? Well, some of the stinky things that they make are things like skunk spray. They're also found in some of those potent cheeses. So think like blue cheese. You'll find thiols in onions and garlic and oysters. So a lot of the things that we link to being stinky have a thiol in them. Okay, so thiols are stinky. We've also used this stinkiness to our advantage. So a lot of the very dangerous gases in our houses are odorless. So what we've done is we've chemically attached a thiol to the gas so that when there is a gas leak, we can smell it. So if you think about a gas leak in a laboratory or even in your house, it has the kind of that rotten egg smell. That's not an innate smell of the gas. It's usually odorless. We have chemically put that thiol on there so that that gas has an odor to it, and we know that it's leaking. All right, so the last functional group for this particular slideshow is an ether. So an ether is going to be an oxygen that has a carbon on both sides. So kind of the mantra that you're going to have here is carbon, oxygen, carbon, carbon, oxygen, carbon. So welcome to Miss Maz's silly brain. Literally, the way that I remember this is an ether is an oxygen with a carbon on either side of it. Yes, I'm crazy, I know. But that's how I remember ethers. So oxygen and a carbon on either side. Fun facts about ether. So diethyl ether has been used as an anesthetic for many, many, many years. So when we first started doing surgeries, we quickly discovered that diethyl ether will anesthetize the patient or the area. So it blocks the awareness signals in the brain. The problem with just plain old diethyl ether is that it's very, very flammable. So even some static electricity in the operating room would cause an explosion. So what we've done is we have replaced some of the hydrogen groups with halogens. So that's 7 column or 17. So we replaced the hydrogens with halogens, and that made them less flammable, a little bit more stable. So here's our ether right here. So carbon, oxygen, carbon. And in regular old diethyl ether, all of these would be hydrogen. So hydrogen, 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 flammable, kaboom. We have since replaced those hydrogens with fluorines and chlorines, left a couple of them hydrogens, but fluorines and chlorines. And this has made that anesthesia more stable. So now when you go in the operating room, you don't have to worry about an explosion because somebody has static electricity. So that's one of the improvements that we've made with these ethers. So that's it for this first half of the functional groups. The other half of the functional groups all have something similar in common. So I'm going to put those in a separate lecture series. So that's your first 3. Hope you found this helpful.